Okay, before we go into this video, this is part of my class, okay? And this is how I projected the universe, galaxies, and stars and stuff as being born, okay? I'm going to show you the birth and the formation, the evolution, and assimilation of the galaxy. I'm going to show you a similar to a birth, which is called the Big Bang, and then the hot matters, and it created like larger clumps of larger sun. Then it's going to become a black hole. From the black hole, where I think it created dark matters. Before that, I call it hot matters. After that, I call it dark matters. After being hot, it becomes cool, which scientists think it's dark matters. But what I think, this is cool dark matters. I'll explain that as I go along. Then we're going to understand the tails in the spiral. Then we're going to understand the crashes and merges of galaxies. And by doing that, it actually makes the galaxy bigger and a longer life of the galaxy. Then after that, it becomes stagnant. And I call it a neutral galaxy. Then, the last part is called disruption. That means it's going to stealing to create a new. After that, would be coming back to here again. Okay? And yes, I believe the Big Bang that created our whole universe, it will die. And I will explain to you why. Okay? At first, I play with soap. And I created the Big Bang. Now, since I left it there for a long time, I only have a little bit left here. Through time, all these will be gone as well. And it will become something like this right here. Let's say pretend that it's not there. It becomes something like that right there. Nothing. Okay? And that's what the beginning of a birth. Now, this is where I created a birth. I took the soap, I put it in the bottle, and I'm going to shake it. You hear me shaking? Okay? We're going to go to 0. 0 is our big bang and formations. So I shaked it all up, and I violently put it in. So now I'm making a new universe. Okay, that's our new universe. Now, if you noticed, there are big, huge blobs. The smaller blobs and the big, huge, all different size. That is number 1, the birth, the hot matters. Remember, those energy is still there. We're going to take the larger sun because it created. Every bubbles in here is a sun. Remember that. Okay? The larger sun will pop. let's say the larger sun will steal the smaller one. It'll merge in together. It'll pop. It'll create a little tiny hole, if you look at it right there. And all the other suns will come in together. You saw that? Now, if I take a smaller thing, and because it comes together, if I continue that, I'm start stealing other suns. If I go really fast, look what happened. It becomes a hole. Okay? If I continue to do that really fast, it becomes a hole. And that's what's called a black hole. The energy around here, that's what's called dark matters. Number 2. Hope you can read. Or see, sorry. So, I created dark matters. And it's grabbing all around. You see that? And if you look underneath there are still uniform, non-uniform suns. But if I stop, everything will go back to where it is. So that means a black hole is what keeping everything surrounded. And look how it steals the other suns. Remember, all these things are our sun, okay? Each one of those little bubbles is a sun. And they all trying to steal the space in here, if you noticed. Now, we're going to go to number 3. Understanding the tails and the spirals. This is the early stage. If you look at it and I do it fast enough, you can see tails and spirals. Wait until it goes back. See that? You can see tails and spirals in that little circle. See it? You can see little ones. Okay? I wish I got color. I can show it. Then, what we are known is called the crashes of galaxies. Imagine if there's one here and one here. One spirals. It crashes together and it becomes a bigger. And if you look at really close, I wish I can slow that down. You saw a bunch of little tails around here because 2 here is making bigger tails and they crash it together. You see that? And then it becomes a bigger black hole. And then it becomes a bigger galaxy. You can still see it. See that? If I just leave it and let it form back, you can actually see that. So the tails and the spirals, it's actually made from the black hole. The black hole is what giving the tails. So it's actually pulling each those spirals to make it. As it eating, it is actually not eating. It is actually making it the energy. So other suns has to die in order for the black hole to continue. Look at how it behaves. If I take this and look, if I have a formation, see that? In millions of years or billions of years, it would create something like that. And see how the chaos of a black hole? Now, if there's 2 galaxies merged together, you will see a galaxy looking like this. An oval shape. Because it's not perfectly round. Perfectly round, meaning it's an older galaxy. But if you see spirals that is messed up, that means it's a younger galaxy. Because it's still trying to balance itself out. Once it balances itself out, watch this. It becomes a nicely circled. And it creates that little center. Sorry if I'm out of the thing. Can't create and film at the same time. You see that? And look at the surrounding of the star of movement. They all move around because the black hole here created dark matters. And then it grabs all the surrounding to go into its center. See that? So if we have leave this for billions and billions of years, the black hole will eat everything, including us. Let's say if this was our galaxy, it would eat us as well. But here's the thing. If another galaxy is over here, and another galaxy over here, they merge together, okay? They create it bigger. That means they will give you a chance, all these stars actually getting a more chance to live even longer. But if we don't merge, we actually will die faster. By merging, it disrupted a little bit. It gives these a longer life. Get it? So let's say two of them merge together. It's going to create even longer life for the galaxies because the black hole is being disrupted. Until both black holes merge together, then it'll start to eat. You see that? As it eating, it bursts the stars, which in this case, the same way, it bursts the bubbles. So as I do this, eventually all the bubbles in here will be burst because of the energy. If I simulate that for a long time, look what happened on around the edges. It's stealing. So no matter where I go, I'm stealing it. And look, there's a region of space now. Has nothing in it. During that time, there's actually new stars is forming because look, there's new star coming up. So new stars, as I do this, new stars on the edges actually forming. New bubbles. Remember, the bubble is simulate stars, okay? So new stars is forming, look at them. It grabs the other ones. As a surrounding, it created new stars around here. So, crashes and merges of galaxy. We are on here now. Number 4. Crashes and merges of galaxies make bigger equal longer life of the galaxy. So as these things merge together and becomes one, it actually makes it longer. It makes all these stars and planets and blah, blah, blah to live longer. Now, once this is all done and it ate everything around, you will see something like this here, just a black hole. And the black hole will neutralize. The black hole will stay just like this because it cannot grow any longer or bigger unless these things are big enough for it to create its energy. So let's say there's a sun here, a bigger sun gives a little bit extra kick. That means the black hole will get just a little bit bigger. So all these stars, if they don't become the way they are, then they just feeding the black hole. The black hole will stay just like that. The black hole is actually is what gives the energy to make our galaxy. And that's what scientists call dark matters. Remember, there's hot matters and there's also cool matters. I believe black hole created cool matters. The birth of the universe created hot matters. This is cool matters. And that's what powering our galaxy. Now, to the last step. It becomes stagnant and neutral galaxy. Okay? There's a big galaxy right now that is actually neutral and stagnant. I'll show you on the screen right now. That galaxy no longer have a black hole, just like here. Someday, when it's all done, it becomes stagnant. Okay? And here's how it's going to become stagnant. Everything's going to go back. And it's going to fill that void. It becomes stagnant. And when everything is eaten, let's say everything else is eaten. Don't pay attention around here, okay? Everything else is eaten. Let me get a bigger stir, because I don't think that stir is good enough to simulate bigger. Oh, I actually have it right here. Let's say I'm going to disturb it, because this is when it comes to violent. When the black hole actually becomes violent, that means it's taking everything. If you look at it, the energy of the black hole gets so big that it's able to look. And that's a simulation of a galaxy as well. If I stop, look. You see the spirals all over the place? Spirals indicating that it's still young. The galaxy is still young. When the galaxy is no longer spiral, it'll create something like this right here. No longer spiral, it means it's been neutralized. You see how that is? Because I'm eating every single stars. I'm breaking them all up. And now look what happened to space around it. There's nothing left. Remember all those bubbles? There was a lot of bubbles. Millions and millions and billions and billions and billions of years. It becomes something like that right there. And it becomes neutral. And that's what it will look like when it becomes stagnant. Number 6. Number 5. This is what is called a stagnant and neutral galaxy. It is no longer have the black hole. The black hole is gone because there's nothing else to feed it. So it becomes a stagnant. This is what I call a stagnant plus neutral galaxy. That means you will see just like that, just like the picture right here. I'm going to show you. That's what it looks like. The last step is called, what I call is disruptions, stealing to create new galaxy. Okay? So let's say there's one right here on this corner and one right on this corner. It's going to steal all the surrounding to make a new. Same thing with here. So basically when it's stagnant, it actually moves out to be neutralized. So other galaxy can steal it. Meaning our galaxy, this is our galaxy and this is Andromeda. Let's say if that was the case, Andromeda did not merge, we would able to steal it and it will be able to steal out. So anything during surrounding of our galaxy and anything around here, both galaxies will try to steal each other. Unless there's another one move in. If another one moved in and it's powerful enough, it will be able to steal all ours and Andromeda. Just an example, okay? So let's say if a galaxy moving towards both of us, it will all merge into a bigger one. And then disruption will start. If you see the disruption just like that right there. And now look what happened. It becomes a chaos again. And it creates a brand new galaxy again. This one's even bigger. And then you can see all the little spirals. Look. I wish I can slow this down so you can see. Maybe you can slow down on your thing. Then, once it becomes a really black hole, it's going to neutralize just like that. Then it can't feed the black hole no more. It's going to come something like this. It's going to neutralize. And it becomes a stagnant, what I call a stagnant slash neutral galaxy. Until somebody comes up and steal it again. So if there's one here stealing, it'll take some of these and it'll go over to here and it'll continue to moving that tail. It'll make that tail again. Unless there's a big star forming. If there's a big huge star forming that is big enough to create a black hole again, then it'll start it again. Then there'll be a new galaxy forming. So if during the time of merging and it's able to make a huge bubble, which a huge star like that, then that star will die and becomes a new black hole. But if small stars is not big enough to overcome gravity, which is fabric of space, it will not become a black hole. It's just going to stay in just like that, where you can see, and you probably have heard of many times, a neutron stars. Well, it's still burning. It just don't, not big enough to steal to create, to bend the fabric, to create this vortex. It has to create a vortex in order to become a black hole. It has to be strong enough to steal. So the energy from that, it has to be strong enough to steal. And look what happened when I actually steal. Look at that. That's in billions of years, in seconds. See that? And that's where the tail creates. You can see the tails. And then during that time, it creates all different suns. See, look at that. If you look really close, they're all different suns. If this one pops, it might create a new hole right there. So in real life, probably a few holes sitting right there all over the place, and we don't even know it unless we see the what they call it, disruptions of surrounding, in order to know if there's a black hole right here. And if that is, it will eventually move into the center to join its parent. So basically, it's like offspring children. That's best way I can explain it. And then someday, when all these are gone, let's push it aside, you will see back to square one, just like beginning again. There'll be nothing left. Let's say if I'm able to remove all these bubbles, all those as the suns, okay? Remember, they are sun. Someday, all these becomes back to the same way again, where we first started, like the beginning. And that's how I understand it. And yes, this is part of my class. And I'm using soap as an example. That's the best way I can try to. And if you leave this long enough, you see the formations? Those are new formations of stars. Because remember, in this lifetime, nothing dies. Because of that, new formations of stars coming up. And if there's enough, if I disturb it enough, I make a big disturbance, there'll be bigger stars just like that. You see that, how huge that one is? There's small ones, there's big ones. But once this is popped, it actually, if you look really close, if that popped, it actually disturbed the space. and it will make an energy form like this right here. And that's how the black hole is formed. See that hole right there? If I pop that, that's what'll happen. If I don't pop it, this is what will happen. I'll speed it up for you. That's what will happen. Nothing created. Only when these big one pops, that's where it creates it. See that? And if I just keep stirring around and around and around like this, look what happened. I'm making my own galaxy. And yes, I can feel the wobbles because space here in here is so thick that I need extra energy to stir. So the black hole is actually eating it. In order for pretend this thick is my black hole, I have to eat something in order to stir this, or else I won't get the energy. You see that? And look how it's eating around there. That's a perfect example right there. Watch. It's gonna steal. See that? It'll steal the surrounding stars to make to go on its own. You see that? Look at the tail. Sorry, I'll do it again. See? Look at the tail. So now it becomes a nice galaxy right here. But this is the disruption of galaxy. And then someday it becomes a stagnant galaxy. Just like that. Nothing. It's just a little thing. Stays in the center, becomes stagnant. Anyway, sorry, my battery died. Now, once it becomes a stagnant, you will see something like this right here. Just a little surrounding. You see that? So when it becomes stagnant, you will see something like that, and you will see just like staying still. It just stays still. It doesn't do anything anymore. And there is galaxy like that out there. I showed you a picture before. That's a stagnant galaxy. And remember, each bubbles is the sun. Each of those suns is, let's say, an average of 3 million light years away. We are seeing so much of it, but they're actually 3 million. Each bubbles, it's 3 million light years from each other. You see how large that is? And remember, there's smaller ones too here. See? If you span it out, look at it. There's smaller ones right there too. But see how it tried to merge it together? It always tried to merge together because each one of those neutralize each other. And that's why it becomes the way. Even if I disrupt it, look what happened when I disrupt it. Eventually, it will push itself back again. Because each one of those trying to steal the space. So the sun, each sun, you can actually measure each sun by the size of it, you can actually tell the distance of it because of gravity. Their gravity actually will tell you the size of the sun and how far it is too. Because bigger, as you know, a bigger person will always power a smaller person. So in this lifetime, or in this universe, everybody's trying to get that little space. If I disrupt it, look, and let go, eventually everybody will try to get that space. See that? Eventually, it will come to neutralized. If there's disruption here, it will even make it that even faster. See? So if there's disruption here, it will make that even faster. So it depends. But as long as there's no disruptions, it becomes stagnant. And it becomes a neutral. And that's how I understand this concept. I was playing with soap, and I sat there and actually was able to figure out how of all these, and then I imagined if the galaxy were each bubble, that's how it would behave. So it behaved just like each galaxy is forming. Let's say there's a big bubble right here, and it created a black hole. Here's what will happen. It'll start eating everything, and you can see the spirals as it move in. I have to use a smaller spoon to create that because I think it's too big. Like right here. Look at that. You see the spiral? See that? Right there. Isn't that awesome? Same thing here. If I create it here, look. You can start seeing the spirals. See? But it will try to go into the center where it neutralizes. It wants to neutralize. Because there's such a tidal force here. Because the black hole made it such a force that it's actually disrupting. And if you notice, this black hole, if this black hole is big enough, it actually would disrupt the next galaxy too. That's another thing that I didn't say. If this galaxy is big, it actually formed this galaxy faster. Watch. See? That galaxy becomes neutral even faster. Because everybody is trying to steal everybody's space. See? See? Depend on how big the black hole is, or the energy of the black hole. And look what happened. Now that black hole actually started merging with this one, because I just ate it. So this black hole actually ripped all those, and now it becomes to here. So this black hole will eventually move into here in billions of year time. So anyway, I hope you will find this video useful. And that's how I understand it. And that's how I put it all together. And I could be 100% wrong. But that's how I study. I've learned how the birth, the formation, the evolution. I cover birth. I cover the formation. I cover the evolution. I cover the hot matters. And I cover the black hole. Then I cover the tails and the spiral. I cover the crashes and merges of galaxies. And I cover stagnant. And then I cover disruption later on. So I cover all that in this video. And I hope that is useful to someone or somebody. But this is my science project. And this is studies of birth, formations, evolutions of galaxies. Other than that, that's about it.